Hello, today I am going to share with you about the PLC mathematical operations for addition, subtraction, multiplication, division, as well as square root instructions. Okay, let me create a new file. Okay, then insert few rounds. Okay, then insert the instructions. Then you can select this compute or math tab, and then you can see these mathematical instructions here: addition, subtraction, multiplication, division, square root, etc. Okay, so I will drag this addition instruction, subtraction, sorry, multiplication, division, as well as square root. If you notice, all these instruction located at the right side, that means it is the output instruction instead of input. So any instruction that put at the leftmost is the input instructions, while those instructions which is located at the rightmost is the output instructions. So all these instruction, mathematical instruction, is output instructions. Okay, so let me give an address. This time I will use the binary. So binary 3 column, maybe word 0 slash, I use bit 0 here. Okay, so I copy down the instructions. Okay, this one I use bit 1, this I will use bit 2, this I use bit 3, and this I use bit 4. Okay, okay, here got source A and source B. Addition means you add source A to source B, meaning source A plus source B, and then the answer will put to the destination address. Okay, so note that source A must be the address. Source B can be address or constant value. All right. Okay, so for example, I will use this integer. Okay, so I will use integer data file. Okay, I'll key in the integer address and 7 column 0. Okay, so I will give a constant value to the source B. Maybe I will put 10. Destination I will put to maybe n7 column 0 slash 1. Okay, oh sorry, 1. Okay, you can also copy the value here. Okay, this I will increase the element maybe to about 20. Okay, looks that is, you see the radius, it is a decimal form. You can click here and choose any form you want, either binary, decimal, or hexadecimal. Here I will use a decimal. Okay, because the value is a decimal value, it's easier for me to see. We don't use a binary because this value is a integer. Okay, n is an integer value. Okay, you can copy down the this address from here by dragging it. Let's say I will use this address, then I put here. Okay, I will use this address, I put here. All right, this example, this. Okay, and then this, right? Okay, all right. Okay, So this constant value, maybe I put 20. All right, and then okay, so let me compile the files for this integer. Okay, this n75 I can give any value, maybe I give 50. Okay, right, let me compile the file to see any error. Yeah, there is a one error, round 3. Okay, okay, destination, I did not enter the destination, so I will use destination 9. Okay, all right, so 0 1 2 3 4 5 6 7 8 9. Okay, 10 11. Let me compile one more time. Yeah, there's no error. Then we can download, save the file into a hard disk. Okay, maybe I will name it basic mathematical. Okay, operation, and then click here, click run. Okay, maybe I can pull down a bit here, and then I click integer here, so they can see the value easily. Okay, you see n75 is 50. There, n75 is 50. Okay, so now it will not perform any operation until you energize the instructions. Okay, so now if I trigger here and I click toggle bit, what happens is this will be energized and then the mathematical operation will be performed. Okay, let me manually trigger it. Okay, let me key the sum value here, n70. You can directly key the value here or key the value at here. Okay, for example, for this one, maybe I put 25. Okay, and then this value I can directly key maybe 15. Okay, so if you key 15, here will appear 15. Okay, here maybe I put 9. You can see n78 changed to 9. This one maybe I put 100. Right, okay, n79. Can this maybe I put 25, 20, make 25. Okay, all right, now we have all the necessary value. N7 2, maybe I put some value, maybe I put 12. Okay, so we got the value here. Okay, so you can see 25 plus 10 will be 35. Right, you see the value changed to 35. Then how about this? If I toggle bit, so you can see -8. All right, why? Because 12 minus 20 is -8. How about this one? It'll be 750 because 15 times 50 is 750. If you want to multiply by other value, you can do so by change the value here directly. Then you can get 115. Okay, okay, this one division, so you get this value. You will see the value here is 0. Why? Because this is n is an integer. So whatever value that you get will be round off. Okay, that's why the value is 0. Okay, for example, maybe this one is 5, you will get 0. Okay, oh sorry, because this one not yet energized, so let me energize it. You get 20. Let's say this one you change to 4, you or you change to 3, okay, you get 33. You will not get the decimal places because this is an integer value. All right, the data file is integer value. That's okay. Later we can, let's say you want to store the answer in that consists of decimal places. So you need to use a floating point data files. Okay, let me maybe go to offline. Okay, let me save it. All right, so I will double click this. Okay, maybe I increase the element to 5. All right, so this I use maybe for the division. All right, I will use this floating point. Okay, and then let me download it one more time, and then run the program, and you can see, okay, 100 divided by 3 is 33.333. This is a floating point value. Okay, the address is this data file type is a floating point. That means it's a decimal point values. All right, so that's it. Thanks.